Okay, Carolina, you tell me when it starts.
Yeah, I think we can start already.
Okay, good. So good morning, and thank you very much for joining our workshop on plug and play interoperability to simplify data exchange. I will introduce the workshop with a couple of slides, and I will introduce our two kind speakers. And so, Carolina, please, next. So I'm Selenia Gedimitriou, and I'm going from ICOR and the University of Modena Reggio Emilia, and I'm going to represent NOUS project. Here with us, we have the first speaker, Professor Ignacio Blanquer from the University of Polytechnic of Valencia. And he is also a EOSC director, Open Science Cloud, of course. And then we have a second speaker, Dr. Juha-Pekka Soininen from VTT, and he is also the DS2 project coordinator. Sorry. So our objective is to start a discussion about this topic on data interoperability. And our two speakers are representing two sister projects of NOUS. So we have to organize a few workshops, 5 to be precise, in the context of NOUS projects, and we are trying to make them useful for us and also for the speakers who will speak later. So next slide, please. Just a very one slide of introduction of NOUS, that is a European cloud platform. And basically, the objective is to develop a platform that combines 3 components. The computational component that execute computation, the edge component that communicate with edge devices, and the data storage component. And this platform will be tested in 4 use cases. Just next slide, please. Just one last slide to introduce our workshop. One of the tasks of NOUS is to develop the plug and play interoperability solution for the data sharing. And here you see a screenshot from the grant agreement. Basically, it's a technology that the project has to develop. And from this task and also technology that we will have to develop, we decided to focus the workshop on data interoperability. So I would like to start with the first speaker, Professor Blanquer, with his presentation on the Open Science Cloud connector, data interoperability connector. Thank you, please.
Thank you very much for the kind introduction and for the invitation to participate. I hope that you can see my screen. Let me just go to the minimum. Yeah, I want to make some a small, puntualization, a small comment before. EOSC is not a project itself. It's an initiative that has many projects around. I will not go deeply to the specific technicalities of the connector that are being developed for data interoperability. We'll try to give a view of all the ecosystem that is related with the federation of nodes in the EOSC environment, with some specific relation with the data interoperability and other technical interoperability of services. So with this, this is basically the outline of my presentation. Start with the concept and definition of EOSC. Is I mean, every single EOSC presentation has to start defining itself, the federation, the concept of the EOSC federation, the implementation of EOSC, and future and conclusions. So first, EOSC as a nutshell. So we have released very recently a document that's that tries to describe why EOSC is a pivotal European activity for the competitiveness. It's a policy action in the European research area that has as a main objective is to create this thin layer that will support the creation of federated structure that we call the EOSC Federation, in which nodes contribute with data to create the web of data and services. So we are not implementing a new infrastructure. We are not replacing the way of the data is being collected and made it interoperable by the different research community, but trying to provide guidelines at central services and other types of approaches to facilitate the multidisciplinary exchange of data. So with this, I will recommend to have a look at this document to have a clearer understanding of what is EOSC and what is the objective. Apologize if you just hear noise, it will stop in a minute. So again, what is EOSC at the level of the governance? It's not one project, it's a co-program partnership, which means an agreement between the European Commission and the EOSC Association, which is an association of more than 250 partners that have agreed on the on one side, the Commission providing 500 million euros in the implementation of EOSC, and the association 500 million euros in-kind contribution from the different partners. Additionally, we have the member states that are represented in a steering board, and every decision at the level of EOSC is taken in this tripartite governance. Now we have a new president, which is Klaus Tottermann, that will start next week. So the most important topic for this workshop, in my opinion, is the concept of the EOSC Federation. So the EOSC Federation is to define this existing work that has been done by research infrastructure that have data and contribute and collaborate between different disciplines and be within the same area of knowledge that, as we have seen in life science, with the contribution, with the cooperation between genomic platforms, biological samples and others, to have a more, I would say, coherent and comprehensive way of interacting with a clear governance and with a clear set of requirements and interfaces for ensuring the exchange of data and services of data. So up to now, the Federation has started with the creation of a new node, a reference node that is funded through a procurement by the European Commission, and it is available in Open Science Cloud eceurope.eu. This node provides computational services, a knowledge graph of the assets that are available, information about the data interoperability and other services for sharing data, exchanging data, and processing data. As a federation of one node is not a federation. We started in this year a process of selecting candidate nodes that could form this federation, and from a call of one in which more than 120 applications were received, there was 13 of them were selected. Some of them are not only single institutions, are collaboration of institutions, and these 13 nodes will form the concept of the EOSC Federation, and it will be demonstrated by the end of this year. Especially, we will have some best practices showcased in November. There will be an opportunity to enroll new nodes from the last quarter of 25 onwards. So let me, and I think this is start to go deeper on what is exactly the concept of this federation and the interoperability at the different levels. The interoperability of the nodes is being defined at different levels. We have on one side the capabilities, in which these are the mandatory services that all nodes have to provide as a federated authentication authorization interface, and service catalogs for interoperability integration, which doesn't mean to have a single catalog of everything, but a set of standardized catalogs that can interact all together. There are resources for federated computing, resource environment, and sync and shares, and other use cases that define the reusability of data like Rihanna, or the one specific on sensitive health data. So these are the groups that have been defined within these 13 plus 1 nodes on constructing the EOS federation. Then let's go to more technical details, and there's a guideline of how this federation should be constructed, which the first document that has been defined is the EOS Federation Handbook. The handbook defines not only technical specifications for the services to be linked, but also operational procedures and governance of the how the federation should be constructed. This is a first draft. The draft is available in Zenodo, and we expect to have a revised version by the end of the year with the experience of the construction of the federation that we are having in this during 2025. So I'll try to extract some details that will align with the plug and play focus of the workshop. So first, defining what is a node. A node is a national, regional, thematic, or even institutional center or combination that provides or infrastructure that provides services that can be interacting with the rest of the services of the federation. So it's important to understand that we are dealing with thematic, that is community-oriented, international. In those cases, they have a very clear, I will say, rules with respect to the restrictions of the data and the community, but also national, that are more catch-all, more long tail of sign oriented, that have this region, the geographical dimension. So in the services that are being provided, there are core services which are required to implement the federation. AI is one of the services. The catalog is another one. Generic services that are horizontal, that can be exposed and used by different disciplines, like the computing, the data storage, the PIDs, etc. Research resources that are specific of the domain, like services for accessing geographical data, or other services that are specific of data coming from a community. And then we also call node exchange, that are services that are exposed outside of the node for other nodes to connect. In this list, the capabilities that every node should have in order to connect with the rest are listed here. The first two are the ones that are mandatory and clearly commented: the resource catalog and AI. The AI should follow the ARC blueprint, which is a model for the integration of different identity providers across Europe. Help desk, service monitoring, service and research product accounting. Monitoring and accounting is key. And another important point is the order management, because some of the services are, I would say, virtually infinite services like a catalog, but some services are rival resources like computing or storage that need to be assigned as a consequence of an application in order to content the demand, right? User space. And another very important service that also is related with the plug and play interoperability is the application workflow management, which is a service that is being expanded in the new versions of the federation, that will be able to take data from specific places, make computing available for this data, and also deploy the software bits required for the execution of this processing or the creation of virtual research environment. This requires a strong and very clear description of the, of all the different metadata and actions with respect to the FAIR principles. So how EOSC is being implemented? So it's not, EOSC is not the EOSC association. EOSC is a wide range community, and there are many projects around this. So the guidelines for that is the Strategic Research and Innovation Agenda, which is a document that guides this co-programmed partnership that has been written by the association with the support of their members. Every approximately 2 years, we have a revision of the strategic research and implementation agenda, an innovation agenda, sorry, that is the multi-annual roadmap that defines the priorities for the next period. And this is an input that is taken by the Commission to define the goals that will fund the activities in the EOSC, in the infra-EOSC destination 2 goals. The last version of the SRIA has 4 strategic pillars, and one is really related to common European data spaces and beyond. And you can see also others that are well related with the interoperability, like the contribution of the FIWARE data and the uptake of AI and the enhancement of the EOS Federation. So who is implementing this? A wide range of projects that are addressing areas like the provision of services, the implementation of use cases, the construction of the federation. And the best way to get an insight of those services is to go to one tool that we have created in the association that is called the EOSC Macro Roadmap, which is a database in a web server in which you can find all the assets from the different projects. So it can be easily found any information that could be relevant for the interaction with the EOSC at large. Another important implementation effort is the creation, the task forces of the association. Task forces are a group of experts, not necessarily coming from the association. We have an important share of experts that come from outside of the application of the association that address specific areas. We have 4 at this moment, one on the technical and semantic interoperability that addresses all the work on the interoperability framework of EOS, as well as the global architecture of the EOS Federation. Another one of FAIR metrics for digital objects, which also evaluates all the compliance with the FAIR principle, which is key for the data interoperability. One vertical on health data. This is the one that I am the liaison of this group that has the interoperability with the European health data space. And another one that is important on the long-term data retention, because preservation should be done under specific conditions. And we are now seeing that preserving all the data generated is not viable. Along with the task forces, we have groups of projects that are also creating effort or aligning effort towards the federation. So very briefly, how is the future? So let me very briefly comment 2 activities that the association is starting. There are 2 projects of the association, the EOS Gravity and the EOS United. Gravity started beginning of June this year. United will start on September. But important thing is that Gravity will have cascade grant for the creation of nodes, of help creating nodes, and also for the cooperation of projects. In this cooperation of projects, actions related to interoperability will be really key. And therefore, that will be an opportunity for projects in the area to contribute and work together. And the other part in United, there is an important focus on the integration of new nodes and the data spaces, which also will be key there. To conclude, so EOS is central to European research and innovation strategy. Addresses the key priorities on data security in societal changes and societal challenges and technological leadership. We are fostering the development of this collaborative environment, and that we think that is key for not only for research but also for innovation. And we are trying to align all the principles with respect to the competitive documents, like the one from Enrico Letta, Mario Draghi, or Manuel Aitor, that are focused on the digital infrastructure and data. So that's all from my side, and I would be happy to have questions in the panels. Stop sharing my presentation.
Okay, thank you very much for this very interesting presentation. I don't know if there are questions. Okay, I will make just one. You said that there are the last quarter of 2025. There might be some calls for the nodes, for the main nodes of the EOSC application. Is that last quarter of 2025 or this year?
Yes, yes. Let me explain two things. One is the calls from, the work program of the European Commission, right? There's one call, which is the InfraEOSC, sorry, 2025-01, if I recall correctly, which is focused on the creation of nodes. This is a funded activity by the European Work Program. This is closing on middle September this year, right? Along with this, we have the call of candidate nodes to join the federation. This is unfunded. These 13 nodes are not being funded for being linked there. This is voluntary work. And this will be open in the last quarter. We don't have dates yet because we are, getting all the experience from the first call. And additionally, sorry, because this is a little complex, there is the Cascade Grant. The Cascade Grant will be additional money that will be given for organizing projects and organizing communities around countries to be prepared to be a node, right? And this will be, I think that this one will be early in the first quarter of 2026. So September, European Commission funds, end of the year or November, more or less, the new nodes unfunded call, January, February, the EOS Association Cascade Grant.
Okay, good. Thank you very much. Just last question, very quick. It's we are all this data we are talking about are research data, or it's more general?
It's research data. EOSC is considered as the research data space.
Okay. Okay, thank you. Thank you very much. I don't know if somebody else has another question. Carolina, you see somebody? No. Okay, good. So thank you very much for this very nice presentation. And we will invite you to other workshops of us. And we leave you to your next workshop. We leave space to the other speaker. So,
Selene, we had some hands
okay.
up
Good.
from Cosmas and Alberto.
Okay, so maybe Ignacio, sorry, we take another 5 minutes from your time before your next meeting.
Cosmas, Alberto, if you'd like.
Hello, can you hear me?
Yes, perfect.
Yes.
Okay, so I think that I don't know if somebody from Unparallel want to speak related to this topic, because as they are the partners involved with the plug and interoperability in NOUS project, maybe they could share with us some opinion regarding this.
Sorry, Albert, I didn't get the question.
No,
clearly.
it's
Sorry.
yeah, it's more related to from our partners because one of them it's contributing in the NOUS project with the plug and interoperability task. So maybe they want to share something with us.
Okay, maybe Alberto, sorry, because Ignacio has another call. Maybe if there are specific aspects we can discuss with parallel on another.
Okay.
Perhaps you can jump to the question from Carlo.
Yeah.
Okay, perfect.
Chat. So Carlo's asking if you are envisaging to consider agentic AI for interoperability.
Yes, there is one call, and there's two calls related to AI, and then one on generative AI in this InfraEOSC work program that have been already open, and they are, also due for middle September. And the one of the generative AI, I think that they cover in the text agentic AI systems. I think it's wider than only the interoperability, but I think that interoperability fits quite well there.
Okay, thank you. Maybe the next, Cosmas, he has another question. Maybe last question.
Yeah, we had one from Cosmas, but I don't see him right now online, so perhaps he's having some technical. Maybe we can move forward.
Okay, good.
At the end if he comes back.
Okay, good. Thank you again. And have a nice day. And we introduce Pekka Sainen.
Hey, thank you. I will not share my screen and then let's dive into my presentation. So I guess you see the screen all right.
Yes, very well.
Yes.
Okay, good, great. So I'm Pekka Sainen from VTT Technical Research Center of Finland, and as said, I'm the coordinator of DS2 project. DS2 is coming from the words data space, data share 2.0. And the idea of the project is to build a software solution for interoperability for data spaces. So we are talking about cross-sectoral data sharing and data sharing across data space boundaries. So this project is one of the sister projects of NOUS. And what I'm going to talk about here is the functional interoperability architecture for data spaces. This talk is based on a research article that is submitted to a journal and it's currently under review. So you will get the kind of a pre-peek on what we are now kind of try to publish as a result of these two projects. So the content of this presentation is that I will first start with the data space interoperability problem, then briefly describe the main principles of our interoperability architecture and the DS2 architecture. I will present some key elements of the system architecture that we have been developing, and then present some key issues from the implementation that we are developing as well. And finally, I will go through a little bit of what kind of models we are having and what kind of use cases we are developing. So, but let's start first with the interoperability problem of data spaces. So the quick question is that how to enable two organizations that are members of different data spaces to exchange data products by using the trustworthiness of their membership in the data spaces as a core in creation of the trust. So that's the kind of main issue that we need to solve. If we first start at what is data space and why we need to have data spaces, then the main purpose of data space is to enable this kind of a contract-based data transaction so that it kind of uses the trust that exists by the implementation of data space itself. So the data transaction itself is executed by a smart contract that includes both the data itself, but also the rights of the data holder. So in addition to just bits, we also need to exchange the rights to use the data for some specific purpose. And in this kind of a data transaction, we kind of need to have a trust between the data creator and data user so that the whole process is in principle possible. And in data spaces, the trust is based on the fact that we should know who are the participants, we should be able to verify their identities, we should be kind of committed to common rules of the data space, we should be able to trust the implementation of the software components that we use in the data transaction, and of course there is this kind of agreed legal principles and law enforcement that kind of creates the trust at the end if in case of any problems. So this is the core functionality of data space, to implement this kind of a contract-based transaction. And then if we think about these kind of main challenges that we have regarding interoperability in this kind of a cross-data space interoperability, then in this diagram we have actually two data spaces which try to communicate with each other. And if we think about what is the structure of data space, it has these 5 different kind of layers that it has to implement. If we start from the bottom, there are these kind of data transfer services, which means that we have to be able to communicate between the data spaces. So each data space may have different type of things. We need to have common protocols, common services, common kind of APIs that can interact. On the second level, we have this kind of contract management issues, how we negotiate and create the contracts that define what is to be done. These have to be also compatible with each other. And the third layer is this kind of a publication and discovery services. We have to have catalogs, and then we need to be able to search across data space boundaries. So there has to be some kind of a unifying things at that level of also. The fourth layer is this kind of a membership issue. In this case, the membership, we don't need to have a shared memberships as such, but we have to be compliant that we trust on the memberships of the other parties. And finally, each data space have their own rules. And then when we kind of try to create interoperability between data spaces, at some extent, we also need to make sure that these rules are not contradicting heavily against each other. So it's a bit of an open question that in what sense, in what is the kind of amount of compliance that is needed at this level. But it's clearly so that the data spaces will not probably agree to collaborate if there are very severely contracting rules. So these are the main challenges, that how do we make these different levels of data spaces to be able to interact with each other. The additional challenges is, of course, that this kind of a collaboration problems, how to make these interoperable services interoperable in sense with the usability, how to make the data space boundaries low or invisible for the end users, because evidently the data space interoperability requires that we shall need to have specific services for it, and it causes overheads. There are feasibility problems related to complexity, how to tackle the diversity of needs and offerings, because the data spaces may be kind of very different from each other, and if the kind of things that are inside them are very different, it creates a problem. And fourthly, there are these kind of deployment issues, how to make adoption of solutions simple and scalable as an opportunity, so that it doesn't cause extreme problems to the participants to take into use. Okay, then the main principles of our solution. So first thing is this kind of technical freedom thing. Data spaces can choose the technologies according to their own needs. There may be situations that we don't have any common technical solution between two data spaces at all. Of course, there is an attempt now at the data space community to create common data space protocol standard and to define common data transaction, but it's not necessary that the data spaces actually apply these, so they may be very different. The second principle is that we have to keep the data sovereignty as a guiding principle in setting up the interoperability solutions. So the control of the data rights must remain from the data rights holder. So also in these use cases that go across data space boundaries. Decentralization principle is also very important because we all need to have this kind of a main idea that confidential things are done between the parties only, so that the data spaces and interoperability solutions don't interfere to contract negotiations or data transactions. So this is kind of a critical principle. Final principle is this independence and integrity of data spaces. They are defined based on their own purposes and own needs, and data spaces need to have this kind of full control for their own federation services and their own operational principles. So this kind of interoperability solution should not get involved, shouldn't mix up with those. So they need to be kept separate in a sense. Okay, our system architecture, this diagram tries to show the main elements of our functional interoperability architecture. We have the data spaces in the right and left side, and in the middle we have these kind of main functionalities that we have in our solution. So, of course, the key issue is this data space interoperability system, which manages the the actual sharing of data between data spaces. Above it is this kind of a governance system. Even this kind of interoperability solution needs governance, because we can't really kind of use the services of data spaces at all unless the data spaces agree on it. And also the collaboration between data spaces has to be agreed. So there must be kind of a governance functionalities that manage this kind of a agreement part, that okay, what is allowed and what is not, and how we set up the links between the interoperability solution and between the data space themselves. Of course, in order to actually implement the data transaction, we need to have direct connections between the participants of the data spaces, and for that we have this interdata space participant service block, which is kind of a basically connector that connects the participants together. And of course, the idea here is that we have a separate connector that is used for these interdata space activities, because we need to guarantee that we have a common technical solution between the participants as well. Then the fourth main block is this kind of a deployment system, which purpose is to provide this kind of a marketplace for our solution, so that the participants and data spaces can implement the required capabilities as easily as possible. So this is kind of a basic structure of our interoperability architecture. So from the ecosystem viewpoint, I've tried to sketch here some of the main kind of organization types that can be involved in this kind of a solution. The core here is the interoperability solution operator at the middle, which actually provides these interoperability services that we need. Then of course, there can be a service marketplace that provides additional services for participants that they can use. We have basically two types of services: interoperability solution services and then another applications and services. So we have, for example, in the DS2 project, a set of tools and applications that help participants to manage their data in this kind of interoperability solution. Then, of course, this interoperability solution provider, it can use different type of intermediaries for implementing federation services or value creation services that increase the value of the interoperability. Okay, let's then go into more details of this data space data sharing system. So the box in the middle now describes what are the infrastructure services that need to be implemented by this interoperability solution provider. So, of course, we need to have a governance layer, which is operated by operator, which manages the agreements and the access, granting access. Then we need to have a set of identity services that provide identities that are needed in trustworthy transaction. So we need to kind of, when we share data, we need to verify the identity of participants. In our solution, it's done in the collaboration with data space identity services. So we actually rely on the identity of the participant in its home data space. So we don't really create participant identities in our interoperability solution. But we need to create identities for participant service components. So we need to verify that the connectors that are used in participant services are trustworthy. We also need to verify that there is an agreement between the data spaces that collaboration is possible, so that we can also kind of define or limit the access to different type of data in data space. Thirdly, we have this kind of a publication and discovery services. There needs to be a common catalog of data offerings in this interoperability solution. Of course, this could be, in theory, implemented with this kind of a federated solution that we access directly participant catalogs. But in our opinion, it's much more easier and simpler to set up a specific catalog between the data spaces and do it in that way, because otherwise this kind of a verification and control problems would be much bigger. Finally, we of course need to have logging services. In IDSA architecture, it's called clearinghouse, but anyway, this kind of a logging of data transaction events needs to be implemented as well. And of course, in participant part, we need to have this participant services, which is mainly the connector. Okay, another part of our solution is this deployment system. Our deployment is based on this kind of a containerization-based runtime environment that is deployed in the participant system. We call it IDT Interceptor Dataspace Toolkit. And this kind of a toolkit, of course, includes the DS2 connector, which is based on Eclipse Dataspace Connector, added with some DS2 extensions. We, for example, have our own policy enforcement module in it and some other extensions as well related to communication between the home data space. But this IDT also has an interface to DS2 operator and model marketplace, and it contains all the models that are deployed by participant. So the idea is that this operator has a model marketplace that can contain basically unlimited number of different applications and services, and each participant of DS2 can then deploy modules on this IDT environment and connect them to its own data management system. All our modules have their own specific UI as well. All the modules that it is relevant to have a UI, and we have a navigation system that can be used to connect the modules together as a system. Another part of this development system is a portal, which is a web portal that supports this containerization of new models and marketplace for them. So each participants that are part of this interoperability need to register to portal, and then they can purchase models and deploy also models to its own system. And of course, this IDT is one of those models. It also supports the model developers that they can add their models to this marketplace so that the users can get access to them. Additionally, we have created this kind of a data pipeline solution that can be used as an extension of data plane so that we can add different functionalities to this data transaction and this kind of a pipeline can be implemented both at the provider and consumer side. So depending on what kind of needs the data sharing contract actually has. The pipeline actually consists of this kind of orchestration module, which can be used for planning the pipeline, and then there is a model repository of models that the participant has deployed, and some of those models are such that they can be added into data transaction pipeline directly. So this orchestrator model, on the other hand, can also be used for controlling this data transaction. So the idea is that we can kind of add in the data sharing contract the guidelines that how the pipeline should be contracted, and when transaction then takes place, the orchestration model implements the pipeline and feeds the data through it during the transaction. We have implemented many modules for this kind of data transformations, quality assessment, curation, data retrieval, that kind of basic data processing services that are applicable in this case. Important part of the interoperability solution is this kind of data models, because we need to ensure semantic interoperability, and we also need to ensure that the system is capable to handle the data. And data product and data product offer model is, of course, the issue here, how we publish the data in catalogs. So this model defines how product offers are presented in catalog, and it's based on the guidelines of Dataspace Support Center. So we pretty much follow the rules of that. So I don't go into the details of this model, but it divides the data product into resources and the data product offer, which is the metadata that we publish in catalog. So we need to describe the data asset and how to access it. But we also need to kind of create the initial data sharing contract so that the potential data consumer can actually review it and then make decision whether to get the data or not. The model is based on DCAT AP format, and the policies are based on the ODRL as proposed and recommended by Dataspace Support Center. Another model is this data sharing contract, which is a legal contract between the provider and consumer that defines what data will be shared, what are the data rights holder, what are the data holders' rights that will be transferred to in the contract, and how the trusted data transaction will be done. So this contract is created after the negotiation process if both parties accept these conditions, and especially this trusted data transaction part is a smart contract that will be executed by the DS2 connector and its policy execution unit. So this contract actually defines how the actual data transaction is then done, like it's done also inside the data space. So the DS2 implementation, this diagram tries to show how what models belong to where. The main elements here are this DS2 operator, which kind of manages the governance with the data space agreements, rules, and participant onboarding services. It also implements the federation services, where the identity management and the catalog are the key things. So we have a common catalog and a common identity model, which actually interacts with the data space identity providers as well. So it's not kind of managing all the identities completely. Then we have a module for data marketplace and another module for DS2 models. So we have actually two marketplaces, one for the applications and services, the model DS2 models, and one for the data itself. And of course, then we have this logging service, we call it DRM module, that records all the events in the data transaction and then can provide the kind of impartial recording of what happened if some problems or mistakes emerge. The another key issue is, of course, this identity model, the Interdata Space Toolkit, where we have this connector and Kubernetes-based runtime environment and support for also to interact with the portal, the model marketplace, so that we can deploy new models there very easily and to manage the pipeline operations. Currently, we have implemented most of these models. We are currently testing the models as standalone models, and the plan is to now start to deploying this as a complete system. We have also some supporting applications that make use of data space easier. I have a few examples here listed. For example, we have this sovereignty decision support model, which is kind of a tool for assessing risks related to data sharing across data spaces. So before companies kind of commit to data exchange or data transaction, they can analyze what kind of risks are related to it. We have another model called Model Development Toolkit for developing AI applications using the data that is shared across data space. Then we have another model for creating dedicated modules for agreements. So it creates the ODR descriptions based on what users define. And then finally, we have also this kind of a discovery, assessment, recommendation, and configure model, which is an LLM-based assistant for two different purposes. One purpose is for searching data products across data spaces. So you can actually search the data products using natural language, and then the LLM tool kind of converts it to search queries and provides better results. Another use is related to configuration of data pipeline. You can use this kind of a similar approach for constructing the kind of a configuration code for the pipeline. So we are developing, of course, use cases to validate this solution. We have basically 3 different use case locations. Each location have 2 separate data spaces with different varying number of members in them. So we have actually 6 data spaces and tens of data space members overall in this scenario. And the idea is that we first develop this kind of a cross data space use cases inside these 3 locations, so that we have use cases that we implement in Romania, Slovenia, and Greece. And in each of these use cases, we mash up data from at least 2 data spaces and create applications and services for end users that show the value of this cross-sectoral and inter-data space data sharing. But we also have this kind of a dynamic 4th use case, which we will implement at the end of the project. And the idea is that when this kind of a structure is complete, you can build new use cases very easily by implementing data sharing contracts between the parties, and then set up the use case without actually any need to modify the data sharing infrastructure at all. So, and in this final use case, we will kind of make maybe a synthetic application, but anyway, so that we actually collect data from all 6 data spaces and combine them to some kind of a combined service. Okay, then finally the conclusion. So DS2 is developing software for implementing this interoperability data processing and system integration services for data spaces and for cross-sectoral business use cases. So we have a set of different services that we implement. We have a modular architecture with container-based runtime environment, and we support the unified user experience, and we have a scalable model marketplace so that this is easy to deploy and easy to take in use. We have very simple deployment and lightweight governance model in our solution, which is compliant with the data space supports and the recommendations. And we are now implementing the validation by 3 use cases in 6 data spaces. So this concludes my presentation. Thank you.
Yeah, sorry, I couldn't find the audio and the video. Thank you very much for this very interesting presentation. And I see perhaps there are already some questions. This component that I have introduced at the beginning of the workshop that have to be developed by NOUS is very, very close to, it's matching very closely with what you are developing in your project. I don't know if there are already some questions. Carolina, could you please check?
Yes, there is one
okay, maybe
question. It asks, what kind of authentication protocols are you supporting? I see that you have some end-user focused scenarios. Do you consider humans as part of the sharing process, or is sharing only M2M?
Well, of course, in data spaces, the the idea of the data space is to connect cloud-based data storages and data assets, or to share these kind of data assets that are in the cloud somewhere. Of course, they can be owned by a company or by a single person. But if you want to be a data space member, you have to join the data space and be a legal entity that acts there. So in that sense, humans can be involved. So and it can be personal data or medical data or whatever data. It doesn't have any restriction to that. Authentication, if you mean authentication of a user from the participant side, it's of course depends on the participant system, what kind of authentication they want to have. In these use cases that we have, this participant authentication is done by eCloak or some another way. But then if we think about this authentication inside the data space, it's kind of depending on what authentication solution each data space uses. And in DS2, we are now thinking of using this kind of a credential-based identities. So, of course, the credentials are created by governance authority of interoperability solution, but we kind of plan to implement this kind of verification from legal entity identity providers, that we check who is who from this kind of trusted sources, which EU is also kind of recommending. I hope this addresses the question. I'm not quite sure, but
All right. So from Stefan, it is answered. Let's see this question from David. It says, regarding the toolkit or software that is being built under the DS2 project, you said that it is open source. I would like to know what open source licenses have been selected and are being used.
Okay, now we have 17 partners in project, and something like 10 of them are developing actually software. There are different license models here. We don't have a kind of a single DS2 license model at the moment, so it all depends on the partner. The aim is to have everything open source, but there may be some restrictions. Some companies are not perhaps willing to put everything in open source, but only part of it. But the aim is to have core functionalities in open source. But of course, this open sourcing will take place probably at the end of the project when things are ready. It's not necessarily during the development time that everything is open.
Yeah.
All right, we have one more question from Ross that asks, does it support interoperability with EDC and FIWARE data space connectors?
Well, I must say that I don't know what's the implementation of the FIWARE data space connector in detail, so it's hard to say, because if you want to, the interoperability of connector level is kind of a complex thing. There are two separate things. One is that it's kind of a technical interoperability. We need to have a same protocol interface in both connectors in order to them to be interoperable at all. And if they do not have, then there must be some tweaks to kind of make it happen. And that's not really kind of an issue with our project. But the second more important thing is that in order to data space connectors to be interoperable, they have to be part of same identity space, same kind of a trust space. And now, if this is possible, that's kind of a big question, which is pretty much unsolved in the data space community, in my opinion. That each data space have their own identity mechanisms for components, own acceptance rules for components. And if you are connected to one data space, it doesn't mean that you are able to interact at all with any other data space. So, because you need to have acceptance and identity from that data space as well. And that currently, I haven't seen this kind of implementations where connector could actually support more than one identity provider. So it's a kind of a thing that it's not really done yet. That's why we kind of want to have additional connectors for data space interoperability, which is controlled and managed by the interoperability provider, interoperability solution provider, and it is governance framework. So in a sense, our solution is, if you are aware of this kind of mobility data space, they also have this kind of interlinking layer, and our solution is close to what they have been planning.
All right. So I think that answers for now. I don't see any more questions here. Celine, if you'd like to conclude then.
Okay, good. Thank you very much for this presentation. We will have, in any case, the opportunity to to speak again during our data space cluster calls. So we will find also other opportunities to cooperate, maybe other workshop. We will invite you in our next workshops as well. And hopefully once we will start the activities in this task, we will have we will speak again and interact again in order to exploit your knowledge and experience in this field, and especially not duplicating what you have already done, which is the main scope of having the sister projects, and most importantly, to learn from your experience. Okay, so I'm going to conclude this workshop, and we will share a summary and an article on this.